Hi, my dear IIT JEE students, NEET students, CBSE students. Please welcome to BMS Academy. This is Mr. BHANU MOORTHY Sharma, Senior Physics Faculty Member. Today, I am going to present video class number 7, conceptual oriented class. Okay, maximum number of students are asking me, sir, please explain constraint relations between strings, blocks, and pulleys in Newton's laws of motion. Then I selected one question which is a terrific and beautiful question they asked in 2021 entrance examination, JEE mains entrance examination. I hope the students will get maximum benefit from this video class so that they can move forward. So how to solve the problems in Newton's laws of motion, connected bodies, strings, constraint relations. So now let us quickly move to video class number 7. So this is the system containing two pulleys, P and Q here, and two strings. String number 1 here, this is string number 1, this is string number 2. Two strings are there, two pulleys are there, and two blocks are connected here. So this is a system containing two pulleys, two blocks, two strings. My dear students, please listen carefully. Now, what is the concept involved here and what is the question asked in 2021? So, if the system is released, if this system is released, everybody knows that heavier body comes down, lighter body moves up. But remember that with the different accelerations they move up. This is the speciality of constraints. Because in Edwards machine, we selected only one pulley, we selected only one string, then two blocks. Then tension is constant, acceleration of the two blocks is constant. But in constraint relations, we selected two pulleys, two strings, two blocks. Okay, there may be more than two blocks also. There may be more than two pulleys also. Okay, there may be more than strings also, more than two strings also. So such type of relations are called as constraint relations. Even the tutors also don't know how the relation or the meaning of constraints. Okay, now I am explaining in this video class. My dear students, please get the benefit from me. Okay, so constraint relation means two systems. The system contains two blocks, two pulleys, more than two pulleys, more than two strings. Now the accelerations are not equal, my dear students. So acceleration of the first block is A1, acceleration of the second block is A2. Now the relation between those two accelerations is called as constraint relation. So constraint relation means the total length of the string is always constant. My dear students, listen carefully this concept. So total length of the string is constant. Total length of the string is constant. The question is, if the system is released, so 8 kg block comes down, 2 kg block moves up with different accelerations. Now, he is asking acceleration of the first body. Acceleration of 8 kg block he is asking, and in how much time it strikes the ground. That is the question. How much time the first body takes to strike the ground. Okay, so we are going to solve this question now. Now let us quickly move to concept involved, basic concept. So here two strings are there. String number 1, string number 2. Two strings are there. Two blocks are here. Two pulleys are here. Okay, P and Q. Now let us select first wire, first string let us take. Okay, the total length of the first string passing over the two pulleys is constant. Let us take it as x1 is a length of the first string, this part, and x1 is also same here. So these two lengths are equal for the strings. Let us draw horizontal line like this. Okay, so this is a string length 1, that is x1. This is the length of the string x1, and this is the length of the string from here to here x2. The total length of the entire string is always constant. Even the bodies oscillate like this, During these oscillations, length does not change. Length of the string does not change. That is a concept. So total length is constant, K for constant. So 2x1 plus x2 is constant here. If we differentiate this equation with respect to time, dx by dt, then you will get velocities. So 2v1 plus v2 equal to constant. Okay, differentiation. Constant means it is 0. Okay, so velocity, differentiation of constant is 0, you know. So rate of change of displacement velocity. So 2v1 plus 2v2, constant differentiation is 0. My dear students, listen carefully. So 2a1 plus a2 equal to 0 because it is further differentiated. So these are the constraint relations between velocities and accelerations. Suppose if the acceleration of the first block is a, acceleration of the second block becomes 2a in this question. In this question, a1 is a, a2 becomes 2a. Why? What is the meaning of minus? Because a1 comes down and a2 moves up. They are moving in opposite directions. So minus represents opposite direction. Okay, now? Now we got finally constraint relation between accelerations. Now our next step is free body diagrams. The first body diagram is free body means what? First body is isolated. Isolated means separated from the system. Just imagination. So first body is isolated. Second point is number of forces should be identified. So how many number of forces are there? Two forces. One is 2T here, 2T here tension, 2T because this is T and this is T. First Y. And sum of these two tensions equal to 2T. In the second string, tension is 2T. Okay. And the weight becomes M1G. So upward force 2T, downward force M1G for the first block. Then the block is coming down with acceleration A. So this is the net force F equal to MA. Okay. Now let us frame the equation. Since the block is coming down, downward force dominates over upward force. So that's why M1G minus 2T equals to A. A means M1 into A, Newton's second law, force, net force. So greater minus smaller equal to net force. So 8G minus 2T equal to 8A. Then we got one equation by taking 2 common. Now let us go to free body diagram of second body. Free body diagram of M2. Isolated. Number of forces are identified. Upward force is tension here. Upward force is tension. And downward force is M2G. This is M2G. M2G. Okay, no? So, and this block is moving up, no? This block is moving up with acceleration 2A. We got here relation. Accelerations 2A. So, greater force minus smaller force because it is moving upward. So, this is dominating. So, greater force minus smaller force equals to M2 into acceleration is 2A for the second block. So, this is a very important point. Accelerations are different for two blocks. So, just free body diagram I selected. Substitute the values here. Mass M2 is 2 kg. So, into G equals to 2 into 2A. We framed another equation. So, by solving these two equations, we get acceleration. Because first equation is added to second, tension gets cancelled, minus T plus T, you will get acceleration. This is the method, my dear students, NEET students as well as IIT students. So, and question to answer now. Now we are going to target question. In how much time this block comes down? Means h equal to half at square. So, S means given here 20 centimeters means 0.2 meter. So, 0.2 equals to half into A we got here 2.5 and T square. We got T value to 4.4 seconds. So, this is the answer. Fourth option. My dear students, this is a method. So, constraint relation means first total length is constant. Differentiator we get velocities. Again differentiator we get accelerations. Afterwards, free body diagrams are selected. Free body diagram of first one, free body diagram of second one. Then solving the equations. If the equations are solved, you will get acceleration relation. And once you get acceleration, question related formula. Question related formula is S equal to half at square. By substituting the value, we get total time. So once the system is released, heavier body comes down and strikes the ground in time t seconds. We have to find out that time. So in 2021, my dear students, they asked this terrific question. Actually, constraint bodies, constraint relations, it's a very difficult and dry topic to explain to the students in colleges and institutions. But physics is a tough subject, but made easy by Bhanu Moorthy sir. So you please contact to this number if you are interested. You like, share and subscribe these videos, and don't forget to press the bell button. Okay, so please subscribe my video channel and I have on my own video channel. Please subscribe this video and share to all to your friend circle nearby. Okay, so my dear students, I started online classes and offline classes. You please contact this number. Early morning classes are there and evening classes are there. Please contact this number and join in this institution. Listen online classes if you are interested. Okay, some beautiful concepts in each and every chapter. So we can discuss such type of problems in nearly 20 problems. Let us discuss in constant relations. Okay, if you are interested, if you join in this institution, online classes as well as offline classes in the early morning hours and evening hours, then it will be maximum benefit to you, and at the same time I also feel satisfactory, because if you get the ranks, then it will be enough for me. Okay, so please listen carefully. Bye, see you in the next video class. As quick as possible I am going to present tension problems only. Once you get the confidence, unless you have the confidence, you can't solve the problems in constraint relations. So let me give 2-3 problems in constraint relations in the next video classes, so that you can understand clearly. For NEET students also, I want to project some tension problems, strings problems in the next video class, as well as for IIT JEE main students also. And CBSE students, those who are not receiving the proper coaching from any institution, then you can join in this institution, so and get the benefit now. So please avail this golden opportunity from this academy. So see you next class, video class number 8. Bye.